Okay, we are starting 4.4, part 2. We're just starting off with listing off the perfect cubes. Okay, so we have our numbers on the left, and then in the middle it's that number cubed. So 1 cubed, or 1 times 1 times 1 is equal to 1. Okay, 2. 2 cubed is equal to 2 times 2 times 2, which is equal to 8. Okay, 3 cubed is like saying 3 times 3 times 3. And can we do that math? Well, 3 times 3, that gets us 9. So 9 times 3 more is equal to 27. 4, this is like saying 4 cubed, that's equal to, well, 4 times 4, that's 16, times 4 more is 64. Okay, 5 cubed is like 5 times 5 times 5, 5 times 5 is 25, times 5 is equal to 125. And the last one I have listed is 6 to the third, which is 6 times 6 times 6. 6 times 6 is 36. Times 6 more is equal to... That one I actually need my calculator. Okay, I don't know 36 times 6 off the top of my head. I can do it, but calculator might be easier. It's 216. Okay, and the list of perfect cubes goes on forever and ever, right? Because any number can be cubed. But right now, this is what I have listed. These are, right here, perfect cubes. They're perfect cubes. 1, 8, 27, 64, 125, and 216. Okay, so that means perfect cubes means we can take the cubed root of those numbers and we get a whole number, right? The cubed root of, let's say, 27. The cubed root of 27 is equal to 3. Okay, moving on. Today, we're going to be learning about the sum of 2 cubes and the difference of 2 cubes. Sum means addition. Difference means subtraction. Okay, so the sum of 2 cubes and the difference of 2 cubes. We have these 2 formulas. Okay, where we take our number that was cubed, put it in front, a and b, and then we have a squared minus ab plus b squared, and then the difference, right, same thing, but just with different adding and subtracting pieces. Let's practice, because I think that might be the best way to get this done. Back to the polynomial. So, we have 64x cubed. Everything in this is a perfect cube, right? We can take the cubed root of everything there. Okay, so we can use one of our formulas up top. Is it the sum or difference? Look in the middle. That's the sum. So we're going to use the sum rule. We're going to bring that down here. Okay, we're going to put that right there, just so we can plug these in. Okay, because that's really all it is plugged in. My question to you guys, 64, what's the cubed root of 64? If we have to go back, 64, cubed root of 64 is 4. Cubed root of 64 is 4. So, this can be rewritten as 4x to the third power. Sorry, I'll underline this in red. That is 4x to the third power. What's the cubed root of 1? We should all know that. It's plus 1. cubed. Okay, now I have it in this form. A cubed plus B cubed. And I'm just going to plug these in. What is A? Well, A is 4x. A is 4x. So we're going to say this is equal to 4x plus B. What's B? 1. 4x plus 1 times A was 4x, so 4x squared. Put that in parentheses, squared. Minus A times B, so that's 4x times 1. And then plus B squared, so plus 1 squared. Okay. Now, can we simplify? We can't simplify 4x plus 1, so that's just going to stay there. We can simplify 4x squared, right? What's 4 squared? That's 16. What's x squared? It's x squared. How about right here? 4x times 1? That's just 4x. And then 1 squared is 1. That is our perfect cube simplified, okay? We're going to leave it in this form when we're doing the difference of perfect cubes. Okay, if I simplified this trinomial on the right, it would be a mess. So we're going to leave it right there. How about this one? First thing I want you guys to identify is what's that sign in the middle? It is a minus. So we're using the difference of perfect cubes. Let me bring this down. The difference of perfect cubes. Okay, first thing we have to do is establish what A is and what B is. So we have to take the cubed root of these two numbers. What's the cubed root of 27? That's 3. And the cubed root of x cubed is just x. So we're going to have 3x cubed. And what's the cubed root of 8? Cubed root of 8 is 2. So we're going to plug it into our formula. We have 3x cubed minus 2 cubed. Now we have an A and a B, and we're just going to plug that into our formula. 3x minus 2. Let me bring this down a little bit. Times, what was A? It was 3x, so 3x squared plus AB, 3x times 2. And then plus B squared, plus 2 squared. Okay, now it's just simplifying. 3x minus 2 stays there. Times 3x squared, well 3 squared is 9, x squared is x squared. Plus 3 times 2 is 6 with an x, and then plus 4. So really all we have to do is find A and B. Find A, find B. Couple more. Is this the sum or the difference? It's the difference, right? So I'm just going to bring my formula down so I can look at my formula. We have the difference of perfect cubes here. What's A in this case? It's just x. So we have x cubed minus, what is it? The cubed root of 125. It is 5 cubed. So that equals A minus B. Well, that's x minus 5 times A squared. Well, A is x, so it's just x squared plus a times b. Well, what's x times 5? It's 5x. Plus b squared. Well, what's b? It's 5. 5 squared is 25. That one was an easy one. Done. Okay. Lastly, factoring still has to do with taking things out. So, my question to you guys is, can we take anything out of this first? Answer is yes, but I'm not sure exactly what we can take out. Let's see. Let's just start with the numbers. These are definitely both divisible by 2. But I think that's more than that. I think they're both divisible by 4. 54, nope, they're not. Maybe they're both divisible by 8? Yeah, nope. So they're only divisible by 2. Okay. So, if I take out a 2 from both of these, I have 2 times. Sorry, what else can I take out? I can take out a 2. So I know I have a 2. What else can I take out? I keep doing that. I can also take out an x squared, right? They both have at least an x squared. So I can take out an 2x squared, and what's left? I have 8x to the third, and I have plus 27. Now, I'm going to look right here and ask myself, is that the sum or difference of perfect cubes at all? And it is, right? 8x cubed, well, cubed root of 8 is 2. X cubed, so that's already cubed. And then 27. What's the cubed root of 27? That's 3. So we can simplify that using the sum of perfect cubes. Let me scroll up here to grab the sum of perfect cubes. There it is. Again, I'm just going to use that formula. I still have 2x squared out front, okay? But I'm only going to focus on what I have underlined in green here. So, a will be 2x, because 2x cubed would give me 8x cubed. And b would be 3. Okay, so I'm going to bring this 2x squared down and put it right out in front. 2x squared. And then I'm going to take this whole chunk and put it in front, or right next to that 2x squared. So it is 2x squared times a plus b, right? A plus b. What's a? 2x plus 3. And that's also multiplied by what's left. A squared. A squared is 2x squared. Sorry. 2x squared minus ab, which is 2x times 3. And then plus 3 squared. Okay. Now simplify. 2x squared comes down times 2x plus 3. Nothing changes in there. Times 2x squared, that's 4x squared. Minus 2x times 3, well that's 6x. And then plus 3 squared, which is 9. Okay, let me double check here. Make sure I didn't miss anything. And we're good. Okay, there's our final answer. All All right, and that is all I have.